Hello, this is Chuck Aviation Instructor, and today we're going to talk about holds. I'm going to recommend the best app you can get if you want to remain proficient with uh, flying holding patterns, and that this will help you save a lot of time and frustration when training for your instrument rating. The app is Pilots Cafe's Holding Trainer, and you can find it in the App Store and Play Store for any mobile device. Don't forget to like my YouTube channel and to visit my webpage. The link is under this video. Let's look at the holding calculator feature and then the practice feature of this app. The holding calculator is very similar to a mechanical holding computer that you can buy at your nearest pilot shop. And this holding computer will help you determine which entry to apply to whatever holding pattern you intend to fly. And this entry can either be direct, teardrop, or parallel, depending on your initial heading towards the fix. That's the present bearing to fix, depicted by the black airplane and black arrow. Also by the inbound and outbound course and heading, respectively, inbound course, outbound heading. And third, whether if the holding pattern you intend to fly is standard with all the turns made to the right or non-standard with its turns made to the left. So let's start by covering certain concepts here. Your holding pattern could be defined by either an ATC request or an examiner request during your instrument rating check ride, as well as defined textually on your obstacle departure procedures, which are published in the takeoff minimums document of the terminal procedures publication. It can also be depicted graphically in a low and road chart, for instance. You can also find it depicted graphically in an instrument approach or an standard instrument departure plate. Now, the word fix depicted in this diagram as the yellow triangle in the center, responds to whatever point in space which can be defined by either a station or a waypoint. Back in the day, we used to navigate by the use of NDBs, non-directional beacons. These days, we still have VORs around, very high frequency, omnidirectional range. And nowadays, we also use a lot of GPS waypoints. Not only we use the station itself, for instance, the VOR as a fix, but we can also identify a different point in space by use of VOR plus some other equipment. For instance, two VORs can help us identify a fix by the use of cross radials. Another another possibility is to use the VOR and DME by measuring the distance from the from the station to a point over its radial. DME stands for distance measuring equipment. Now, since I mentioned the word radial, a radial is nothing else than a line that travels outbound from the fix in all directions, starting in and measured in degrees, starting in degree 0, matching the north, counted clockwise all the way up to 360. 360 or 0 degrees is the same, are two ways of referring to the same north. A radial comes from the station outbound. The problem is that when you're flying a holding pattern, you're tracking that radial inbound. Your plane is over the radial, facing towards the station. So your inbound course is going to be the reciprocal of your radial. For example, if this radial is 060, your inbound course is going to be 240. It's the same as the runway labels. Runways are labeled according to their magnetic heading. If you're holding, if you're lined up and waiting for takeoff in the numbers of runway 24, your magnetic heading is going to be 240. Now, when airplanes take off against the wind, but if the winds change, you would use the opposite side of the runway for takeoff. You would be using runway 06. For instance, at my home airport, Van Nuys, in the San Fernando Valley north of Los Angeles, I have runway 16 right and the reciprocal is 34 left. So looking at the runways and their reciprocal labels can help you get acquainted with these numbers, which course is the reciprocal of another one. Now, a faster way to compute this if you don't happen to have flown recently to a runway with similar numbers is to use the +2 -2 method. And again, you disregard the unit number for the degrees, but you will use the tenths and the hundreds. So 0 + 2 is 2. 6 - 2 is 4. And we can use it in the same way here. 1 + 2, 3. 6 - 2, 4. Or the opposite way around with the -2 first. 3 - 2, 1. 4 + 2, 6. If you subtract 1, you add the other. So first subtract, then add. 2 - 2, 0. 4 - 2, 4 + 2, 6. 2 - 2, 0. 4 + 2, 6. So that's how you differentiate a radial from an inbound course. In the holding instructions, when you find the word from, it refers to the radial. Outbound. And when you find the word to in your holding instructions, it refers to your inbound course. Either words can be used to define the hold. The same hold can be defined with either your inbound course or your radial outbound. Let me show you examples of that. In the practice portion, for example, here you see bearing 2, the wipes intersection. That means your inbound is 281, your inbound course, and your outbound heading, or the radial, is going to be the reciprocal 101. And that is what you get to visualize here. The goal for an instrument rating applicant is to be able to visualize the red oval depicted in in the in the holding computer on top of their heading indicator. That's what you aim for when you're training for your instrument rating. You should be able to mentally calculate and visualize the red oval on top uh, of your central airplane in your heading indicator. That way, you get to determine whether to make a direct, teardrop, or parallel entry without using or needing the help of an external device such as the holding computer, be that the mechanical or the digital one. Now, why do we say inbound course and outbound heading? What is the difference? Well, the inbound course is a course because you track it into the station. You're tracking this course into the station from your present position, and for tracking that, you keep a needle centered. Your frequencies and GPSs are set to the station. By the way, to make a GPS waypoint behave as a station, you would press the OBS button. This would interrupt the sequencing from one point to the next, and would uh, keep you uh, keep you oriented to that waypoint, even though you cross it several times while holding. On the opposite hand, a heading is not a needle you keep centered. It's a heading that you estimate at the beginning by using the reciprocal, but after the second lap, you will use to correct for any wind drift that you may find, pushing you away from your inbound course or into the inbound course. If the wind is pushing you into the inbound course, you will correct outside the hold. And if the wind is pushing you outside of the hold, you will correct into the inbound course. And your correction will have to be somewhat larger than what you normally would hold for one leg because you have to account for the wind drift of one, two, and three legs. Now, in the fourth leg, you don't need to keep a wind correction because you will be using a crab angle as you track the needle and keep it centered. So that's the difference between an inbound course and an outbound heading. Okay, to finish, let me depict the importance of choosing the correct entry. And let's use this hold as an example. Your initial heading towards the fix is 090, and you have been asked to hold on the 358 radial with an inbound course of 178. You're supposed to make it a parallel entry according to the holding computer. What would happen if you made a direct entry? If you made a direct entry into this hold, the turn would look something like this. You have to cross the fix, that's the thing. And after you cross the fix, you start turning, and your turn is more than 90 degrees. And as you turn, you cover a distance. And the problem with covering distance is that the holding pattern that has been published or assigned by ATC is only guarantees obstacle clearance protection from obstacles within its limits, which are your inbound course plus 2 nautical miles and also 2 nautical miles on either of the other sides. If you exceed those 2 nautical miles, you may encounter obstacles like mountains. Keep this in mind, especially if you're flying in mountainous regions. And that's the reason why it's better to make a shorter turn. Even if you still have to cross the fix, you will remain within the protected area and then proceed with the parallel entry. So when you're doing the exercises in the app uh, that require a parallel entry, I would recommend that you follow this procedure. You consider what your first turn is going to look like. And this procedure also works for teardrop and even direct entries. So if it's direct, your first turn would be in the same direction as as the holding turns to the right, turning right, and also turning right outbound. That would be a direct entry. Turning right to the outbound heading of 358. Now, the parallel entry, the first two turns will be opposite to the general turns of the holding pattern. In this case, it's a standard pattern with turns to the right. So in a parallel entry, my first turns are going to be to the left. Left 358. My next turn is also going to be to the left. what heading? It's going to be for the inbound course plus minus. In this case, it's minus because it is to the left. Left is least. So my inbound course is 178 minus 45. And I could do the math and tell you that it's going to be 133. But you don't have to be so precise. Keep in mind that your heading indicator in most airplanes contains these markings in the cardinal points. At least the markings every 90 degrees. And most of them also contain the markings every 45 degrees. So you set your inbound course and then you just put it towards one of these markings on your HSI. So how does that look? Well, you set your inbound course of 178, and then you still continue to turn a bit more to the left, heading 133. So after you finish that turn, you're actually gonna have this. 178, and your heading is going to look like 133. But again, you don't need to do the math. Whatever heading it is, you're looking for your 178 on your 45-degree shoulder. So my second turn is going to be left 133. And then I'm going to intercept. My needle's going to center at some point. The sooner the better. I want to have enough space to track my needle, to feel any need for wind correction so that I can apply that wind correction later in my outbound leg. So if I have a headwind that is pushing me towards the station, I may want to increase my interception angle. Rather than 45, make it 50 or even 55 degrees with a headwind, in order to have more time to assess the wind drift, the lateral wind drift that I may have. On the opposite hand, what if I have a headwind that is drifting me away from the station, making my inbound leg larger? In that case, my interception angle can remain 45 or can go as low as 40 or even 35. And it will not affect because I will still have enough time and distance to assess my wind drift when I'm tracking that needle inbound. So this is inbound plus minus 45, and this 45 becomes more with a tailwind. And then my next turn and all the turns after this one, once established, will be to the right. right 358, right 178. And again, right 358, right 178, right 358, right 178, and so on and so forth. So this is how you brief a parallel entry. Now, in a quick glance, I can tell you that if your present bearing to the fix, your initial heading with which you're homing the fix, and your inbound course are more or less similar, and there's uh, quite a margin for that similarity, plus minus 70 or 100 to the other side. If if those if your initial heading and your inbound course are quite similar, most likely you will be making a direct entry. Now, if you're not making a direct entry, it's either going to be teardrop or parallel. How do you know if it's teardrop or parallel? Let's extend the black arrow on this uh, on this picture, and your black arrow would put you outside of the um, of the red oval. If extending the black arrow, if not changing your heading, if not making a turn once you cross the fix, leaves you outside of the holding oval and protected area, then you need to make a parallel entry. If extending your heading puts you inside the protected area, then you make a teardrop. Outside parallel, inside teardrop. Okay, that said, let me show you how to make the most of the practice feature of this app, Pilot's Cafe Holding Trainer. When you receive a holding instruction in the practice section, you can disregard the name of the waypoint, the name of the VOR, the name of the NDV. Just call it whatever fix is your favorite, whatever fix is your nearest, whatever fix you think you're going to be holding around the day of your check ride. The name of the fix doesn't tell you anything new. Remember the three things you need in order to compute your holding entry. The first one is your initial heading. The second one is your inbound and outbound. In this case, notice the word to. That's your inbound. 336 is your inbound, the fix. And then you're going to be making, this is the third thing to consider, turns to the left. So this is going to be a direct entry. In this other example, you have the word radial instead of the word bearing to. That means you have a 023 023. This is not your inbound course, this is your radial. So the reciprocal plus 2 minus 2, 203. 203 is going to be your inbound, your initial heading 055, and then you're going to make a turn to the left, the other left. So notice how you end up inside of the oval if you continue to go straight after you cross the fix. So I'm gonna make a teardrop entry. And this looks better than my drawing, but I was able to visualize the oval before I press the visualize button. That is a skill you'll be able to replicate after you play with this app for a few times. And this is how you brief a holding entry and uh, in general how you fly a holding procedure. I hope you enjoyed today's lesson, and if you want to uh, have a session one on one with questions and answers that may have arisen from this discussion on holds, or if you want to discuss any other instrument procedure, I'm a CFII and advanced and instrument ground instructor. I've been a pilot since 2013. I'm based in LA. We can have sessions face to face or via Zoom in any part of the country. Feel free to send me a text. My contact info is on my webpage, and the link to my webpage is just below this video. Thanks for watching. Don't forget to subscribe and share this video with your friends. And see you next time. This was Chuck Aviation Instructor.